By choosing to write this such that our variables are A and B, and when A and B are both 0, we're in the no advising group, we've chosen beta 0, the no advising group, as our baseline, and the other parameters, the other values of beta that we're going to estimate, are going to reflect how each of these groups differ from this group we've selected as the baseline. How would we estimate these quantities? Well, in the most straightforward way we can think of, our estimate of beta 0 is going to be equal to the mean in the no advising group, because that's what it represents. Okay? Our estimate of beta 2 is going to be equal to the mean in the B group minus the mean we observe in the no advising group. Our estimate of beta 1 is going to be equal to the mean that we observe in the A group minus the mean in the no advising group. So if you tell me the mean in each of these three groups, I can give you back my estimates for these three betas, and so I can give you this equation. And now if you come in and you tell me you have a new student, all I have to know is whether she's in group A and whether she's in group B, plug in those values, and I can predict the mean. This relates to our idea of separate means models versus equal means models. Right? The equal means model is what we would get if beta 1 and beta 2 were both equal to 0. Then we would say, regardless of whether you're in A or B, we have only one prediction. Right? Beta, there's no difference between group A and no advising. There's no difference between group B and no advising. Whereas the separate means model is the one in which beta 1 and beta 2 are both non-zero quantities. A separate means model is the one where these are all three different numbers, where the means are different in every group. And so the hypothesis tests we would run are for whether beta 1 is different from 0 and whether beta 2 is different from 0. Because if these quantities are equal to 0, that tells us that some of these groups actually have the same mean. And so we'd be looking to see whether the data gives us enough evidence to reject the null hypothesis that actually the equal means model is sufficient. And we don't need the beta 1 or the beta 2. What's the benefit of writing this as an equation? Why do we want to write this as an equation if all I'm going to do is estimate the mean in each group? The benefit of writing this as an equation is that if I want to add other kinds of variables that are not 0 or 1, I can do that and still predict the mean. So next we'll talk about an example like that.